Okay, hello students. I would like to walk through the practice problem for lesson number 4.4.5. So this is on how do we switch from logarithm to exponential, and how do we switch exponential to log. Look at the simple question they asked. We've been doing this from, I think, algebra 1 or algebra 2. They gave us 1/3 of raised to the power x is 9. Remember, the definition itself is if b raised to x is some y, that means, so the input here is the input and this is the output, then we use the logarithm of y becomes the input, and this base goes down this way, and the answer is x. That's all it is. Now, in this example, the b that you see here is 1/3, right? This is 1/3, and that is x, and then so this is your y. So this is b, right? So let me clean this up. So B is, let me put B is this. Let me put red is X. Oh, no. The red is already there. Let me clean this. Let me put something. So this is your X. And the red is the 9. So all you do is you write the logarithm of, so you write logarithm, and the blue color, the base, this is the place, see, because you are raising something to it, right? You are raising something to it. Because you are raising something, it goes 1/3 down, you see. And now that is done. Now the red one, the red was the output. This was the output. But now the output is the input. Okay, and then the input, which was x here, exponent for 1/3, now that changes to x. So that's all you're supposed to write. The question here is, what is the meaning of, I always like to show what does the logarithm of 9 means, and this basically means you're just asking, how many times do I multiply 1/3, 1/3, 1/3, 1/3? How many times I do multiply to get to 9? And you can see it will never happen because 3 square is 9, right? So 2 times 3, when you multiply 2 times is 9, but now you have 1/3. It means we have to multiply 1/3. So, so this 9 is 3 square, but here you have 1/3. So that means you just use 1/3. How many 1/3 do we multiply to get? And you can say, I'll just write 2 of them. That's because if you do this, you get 3 square, and I can always write is 3 raised to minus 2. There you go. So the question of how many times do I multiply is minus 2 times, because not 2, but we say minus 2 times, and you can see why it is. We get the 9. So anyway, they didn't ask us this question. It's just asking you solve for x, and you're done. Okay, let's do second question. Find the solution of the exponential thing. If you look at this, uh, remember the another thing I did forget in the last video. If you have b raised to x and b raised to y, if they have the same bases, when bases are same, I'll do the plural, bases are same, are equal, then the exponent also have to be same. And that's why we say you just cross out is there and you write x equals y. Now if you see this part, e raised to x squared is e raised to 16, they have the same base natural number e. So you just cross it out and say, hey, x squared is 16, and you can solve this as plus or minus square root of 16, which is plus or minus 4. That means there are two answers. One answer is plus 4 and other one is minus 4. And both answer could be taken. You can see you can put this and put this, you get back the same thing. But when you're putting in the, maybe in your homework engage, you make sure when you put it, you put minus 4 and with the comma plus 4. You're done. Find the solution of exponential equation. Now the exponential equation is given. So how do we know what is x here, right? So are you going to change this to in the logarithmic form, like logarithm? You can. I'm not saying no. You can do logarithm of 16 to the base 4, and you can write it like x minus. That also is correct. And you know 4. How many times 4 multiplies to get 16? And so it is 2. So this is 2, and so easy. So but not always going to be so easy. But another way to do it without logarithm, we can write that. So the 16 can be written as 4 square, because 4 square is 4 times 4 is 16. So that's why I can write that. So the 4 is the same, and so not much, and you get the answer and you're done. So sometimes they ask you question, is one thing exact solution? So what is the difference between exact solution and using the calculator? And they may ask you to put it in some decimal form, whatever the value is, and after that decimal, maybe 6 places. They can ask you 6, 7 places. Now, if this is the case, let's do. So the question is, can we use exponents only to figure out exponents? No, that's not possible. So the best way is is convert this into logarithmic form. That means b raised to x is y. That means logarithm of the output y to the base b is the input of the output. So that's what we are going to do. Change this to, so this looks a little small. So let me make it a little big here. Okay, here. Let me write it here. I'm tired. Okay, so e raised to negative 4x equals 3, right? So the base here is the b part. Let's see the base. This is the this this is the base. This is the base, right? So when you write the logarithm, the base goes down. That becomes the e right here. Now the input, the output, which is the 3, this is the output, now becomes the input right here. Okay, and the input, which is the black color, let's say this is negative 4. This negative 4x become the output. That's all it is. And since we need to solve for x, the x has to be by itself. You can't have anything multiplied, divide to x, or added to x, subtracted. You have to have x by itself. So you divide by negative 4. See? And this negative 4 crosses out, and your answer is the same thing we can write as. So your answer is this x stays, so this x, and your answer is done. Actually, this minus, you can write it as minus logarithm of 3 to the base e and divide by 4. But remember, this whole thing, the log has the base e, which you can also write as minus ln. See, instead of natural log, because the base is e, so you use ln, logarithm of natural base. That's what it means. And you put 3, divide by 4, and you're done. So this is the exact value. And you can put it on the calculator. So let's put ln of 3. So go back here. So where is ln? You control, and there you go ln. And you can put ln of 3, right? Minus, I think before there's a minus, ln of 3, and then divide by 4, and then control enter, and you get, and that's it. That's all it is asking you. Or you could also use this one log, and then there was a minus there, so put a minus, and then here 3, and this one you have to put a e. So where is e? So e will be here, and not there. You'll have to click control and there, and then put a e here, and then control enter. You get the answer. Did I miss something? Yeah, I think I forgot to divide by, and then divide by 4, and then control, and I put control enter. You can see you have the same answer, this one. And make sure you round it to the nearest here. This will be, I think this is the, no, I think this one. Okay, so so it was going to be 3 here. Okay, let's do another problem where sometimes the bases are different. Let's look at this problem. This is practice problem number 5. And the first thing what I'll do is, because there are 3 different ways you can do this, and you wanted to figure out what is the x exact value. The best thing is, let's take change is to apply logarithm both sides. So we'll say take the logarithm for the left side, and I'm not writing anything here, assuming it is like a 10, so I don't have to write that. And on the right side, okay. So as I said, if it is log to the base 10, you don't have to write. Now use the laws, like log of m raised to n is n times log of m. So multiply the x, this x will get multiplied right here. This x plus 1 will get multiplied here. So this will be x times x plus 1 times, and then I'll have to write down logarithm of 4, and this will become logarithm of 3. And then we can write equal sign. So this becomes x log of 4, and use the distributive property, that becomes x. Okay, and then you multiply here, it becomes just a log of 3. Okay, now let's bring all the x's together on the left side. So subtract x log 3 this side, subtract x log 3 this side, and you change, this goes away, and you can see this part and this part. You can see there's a x which we can pull out. So I can write directly one step here and write this will stay log 4 and minus log of 3, because there's a minus. So this x which you see, let's see, let me use the black color. So there is a x here, there is a x, right? So that x is pulled out under distributive property. This log 4 stays, so that's right here. This log 3 stays, and that's how I got, and then divide by, okay, sorry. So you're done. And then after that, you divide by this whole thing, because you want to solve for x. You want to keep x itself. So you minus log, you divide this one and divide here also. So this crosses out, and your final answer is x equals log of 3 divided by log of 4 minus log of 3. And you're done. So this is the exact value. But if you want to put it on the calculator, you can easily figure out. The question is, there another easy way to do this? I know you can do this on the calculator. So I'll remember log of, I did not put the base, it means it is the 10. So you don't have to. You can change any. I did in the beginning, I wrote log to the base 10 both sides. You could have said, oh no, I want to put ln to both sides and put this way also ln of, and do the same thing, and you can continue the same answer. But the question is there another easy way out? So this can another strategy. I'm using the same problem, but I'm going to use this one as 4 raised to x. This we can write it as 3 raised to x times 3 raised to 1, right? That's because of a raised to m plus n is a raised to m times a raised to n. Now, why did I do this? Because on both sides, you can divide by 3 raised to x and 3 raised to x, so that uh, I want to get everything in x, because you can see the exponents would be the same. They have the same exponent. You can write 4 by 3 only once the base. So quotient of power, it is a raised to m, and it is also a raised to n. Sorry, if it is b a m and this is a n, this is a n. I think I made a mistake here. Okay, so there's another way to do this also, and that's what I'm trying to show. Let me see if I can do it right here. Oh, I was doing it here. So, yeah, you can write this way and you get 3 there. Okay, 3. And then you can write this in the logarithmic form. So we can write this as the logarithm of this is 4/3. The base becomes the 4/3. The output becomes the input here, and the input becomes the output, and that's all you put on the calculator. You get the this also is correct. So I hope that works. Let's go to the next. Okay, so this question is again a little tricky here. Watch this again. I would just apply logarithm both sides. So when you apply logarithm both sides, and I'll use log of 10, and this will become 3 raised to 7 of x plus 1, and equals logarithm of 7 raised to x minus 3. Remember, this is 10. So, and then this is the power exponent using the logarithm of m raised to n is n log. We can use this and I'll multiply this side. So you get 7x plus 1 into logarithm of 3, and this becomes x minus 3 because this is the exponent gets multiplied to the log, and you write log of 7. Then divide by log 3 because log 3. So before dividing, I think we'll have to do is use the distributive property. So let me take this off. So multiply log 3 from distribute from right side. So this becomes 7 of x log of 3, and then multiply 1. Log 3 will stay the same. This log 7 times x will be log of 7 times x. And then log of this will be minus 3 log of 7. Now, what I'm going to do is we need to get x's on the left side. So subtract log 7, and so log 7 times x time. I think I'll put x. This side is better. At the same time, you also subtract this one minus log 3 this side and minus log 3 this side. So that way this crosses out and this also crosses out. And then you can see over here there's a x. That's our focus. X is common, so it is x. Undo distributive property. This will remain 7 log of 3. Then this is minus log of 7. On the right side, that will be both minus. Finally, what you do is divide by 7 log 3. So your x becomes equals. That's the one. That's the final answer. But you can also, because if there are two minus, you can make it both plus and swap this. Change the order, because if you write this, so it was like minus a minus b, and there is also, let's say, c minus d. You can also face right minus of a plus b, c minus d, and that is same as a plus b and d minus c. So you can write this as 3 log of 7 plus log of 3, and then write log 7 and then minus 7 log 3, and that's the exact value. And if you want to write the calculator, you please put in the calculator and get the answer. Okay, let's do complete practice problem number 7. You are given an equation. In the equation there's an exponential function, You're supposed to find what is x in terms of logarithm. There has to be some log. That's all what we need to figure out. And then not only that, so you're going to get the exact answer in terms of logarithm. And also you want to find using the calculator. All I would do to solve this kind of problem is, how do I change this? The e raised to minus x is down, right? So what I'm doing is multiply both sides. So let me write this again. So this will be 12, 1 plus e raised to minus x equals 2. So multiply, or you can see there's the 2 right there. You can also 2 divide. So you can divide 2 and you get 6 over 1 plus e raised to minus x equals 1. And then you times 1 plus e raised to minus x on the left, and you also multiply 1 plus e raised to minus. Why do we do this? This goes away, so that now anything times 1 will be the same thing. And then you subtract 1, both sides you get 5 equals e raised to minus x. Let me write this e raised to minus x again here. Now some textbook says, okay, apply ln of e raised to minus x, ln of 5, and this LE. I mean, you don't have to do this, you just have to change from exponential to logarithmic function. So this can be written as, this is the input, right? The base is the e, so logarithm of base is e of the input. The output was 5, now it is input, and this is minus x. And then this is, you have to divide by minus 1. At the same, when you divide the logarithm, you can write it ln of 5, and you're done, minus, because there's a minus. And this is how it is. Put in the calculator, you can get the decimal form. But here, this is the exact answer. So that's all you're supposed to do. So you may say, hey, you don't want to divide. Okay, you don't divide, that's fine. You can still continue doing the without division also, and just, okay, but times 1 plus, or you can use the cross product. Look at this. This is 1. It's just use the cross product. And you can write 2. This equals 2 times 1 is 2. And 2 times this will be plus. And you can work this out also. Subtract 2. And you'll see you end up getting the same thing. Okay. Okay. Practice problem number 8 is, watch this. Now there are 2 logs here. And the right side has 1 logarithm. All you're supposed to do is solve a logarithmic equation for x. So I'm going to try to combine these 2 logs, because logarithmic log of m plus log of n is log of m times n. So I'm going to multiply these two. So this is like m, and this is the whole thing is n. So you write log only once and multiply the 2 and get x minus 5. So this thing equals logarithmic of 2x. Remember, there's no base. No base means 10. So this both are both 10, 10. Now when the logarithmic of p equals logarithmic of n is q, and when both logs are same, this means p equals q. That means this log crosses out, and you get, at the same time you can use the distributive property and write like this, and you get 2x. So therefore, you can get everything on the right side, left side. So you get x squared minus 7x equals 0. And not over, you can see there's x squared, there's an x, so I can write can you apply undo distributive property, and you can write this way. There you go. This is the equation, and now you can finish the problem. And so from here, okay, let me write this again. And say either use the zero product property, says either the first one is 0 or the second one is 0, and you can get the answer. So this is one of the answer. You can add 7 both sides, equate, you get these 2 answers. So you can put a comma and 7, and this is the final answer for the 2 equations. So sometimes they give you something like this. This is problem number 9, practice problem, and there's a 2 here. All it means I can just write log of 10 to the base 10, because 2 is 2 times 1, and 1 is I'm using log of 10 to the base 10. So the question is why? Because this is 10 here, that's why. And you can see this 2 you can write as 4x. So this becomes logarithm of 4x plus 9 is logarithm of 10 squares. See? So that means 10 square is 100. That means this thing is 100. So you can just work this out and you can get the answer. Subtract 9 and divide by 4. But is there another way to do this? You can directly also change this to exponential form. What it means is, when you look at it, this log is already, there's a log 10. So this is the input and that's the output, right? So when you try to write that, that's the base. This is the base. So the base is 10 and the output is this, or 2, which goes up here as the input. And the input becomes, this is so simple. And you get this, the same thing what we did right here. I hope that works. Let's do another. Another practice problem number 10 is sometimes they give you logs on both sides. It's as good as saying, okay, 2x. See? And then you're back to your fifth, sixth grade maths where you just have to subtract x both sides and subtract 3 both sides and you get x equals minus 12 and you're done. Now again you want to solve for x. All you do is, I mean these are so I would just add subtract 3 both sides so that I want to have only log on the left side first. Okay, so this goes away and you get log of minus 1 because that's plus 2 and minus 3. Now dividing by negative 1, you get logarithm of 7 minus x equals 1. And what does it mean is that's a 10, right? Of course, when you have a 1, it means the base, this and this is the same thing, right? So it's like 7x, 7 minus x is 10. That's it. Or if you want, if you forget, you can just apply your converting to log to the exponential form. The base is 10 here, so 10 raised to the output is 1 is the input which is here becomes the output. And you solve for x. So how do we solve for x? Is just subtract 7, then divide by minus 1. And you get x equals minus 3 and done. I hope this helps. So again, change the same thing. This is problem number 11. Practice problem number 12. So now again, I'll write along this and this I'll put 2 right here just to show the difference that this is the base, this is the input, and this is the output. So when you change this to the exponential form, the base becomes 2 and the output becomes 3 and the input, this big thing becomes the output. That means this equals x squared minus 2x minus 27. And 2 raised to 3, this is 8, right? So this becomes x squared minus 2x minus 27 equals 8. If you subtract 8, you get x squared minus 2x minus 35, 0. And you can see, you can easily write this as x, and 7, 35. We can split as 1 times 5 times 7. And there's a minus sign, means you have to subtract. That means one of them has to plus and minus, right? And you have to get minus 2. So the big one takes minus and the small one takes plus. So that means it is plus 5 and minus 7. And then you can use the zero product property and say either this is 0 or that is 0. And you can directly also write opposite of plus 5 is minus 5. Opposite of minus 7 is plus. These are the two answers and you're done. Now, question number 13 is there are 2 logs on the left and on the right side there's a 1. And there's a plus 1. So first of all, first we can do this log of m plus log of n. We can write a logarithm of m times n, right? So we can combine this with the base 8. So there's a log with the base. So there's a log with the. I'm going to write log to the base. And now you combine this thing, multiply this thing. So x minus 4 gets multiplied to x plus 3. And the right side is 1. And use change this to the exponential form. And that the base is 8. So 8 raised to output become the input. And the input. And at the same time, I want you to also expand this. What does that mean? You use FOIL method, box method, whatever you want, distributive property, and you get x squared minus x minus 12. So this becomes x squared minus x minus 12, and then subtract 8, and you get an equation x squared minus x minus 20 equals 0, which you can factorize as xx. And this if to 20 we can split as 4 times 5y, because plus 4 and minus 5 gives minus 1, because there's a minus 1 here. And that's why plus 4 and minus 5 will be and the opposite of my negative 4 is 4, opposite of negative. That's it. Practice problem number 14 now. What's the difference between 13 and 14 is there's a, sorry. And yet again the same question. You see there's a plus, so this is like m, this is n. You write only one logarithm to the base 2, and it is x times, so the x is times x minus 2 equals 3, and you can do two steps together because you want to change log to the exponential. The base is 2, so I'm going to write the base 2 first. The input becomes the output, and the output at the same time use the distributive property, write x squared minus 2x. This will be 8, and then I'll subtract 8 both sides, and writing the shortcut here, this becomes 0 equals x squared minus 2x and minus 8, which is same as like this. And we can factorize, put x here. What are the factors of 8? 8 is 1 times 8, right? 8 also is 2 times 4. But because there's a minus and you want to get a, when you subtract, you want to get a 2, 2 and 4 are the best choices. Because there's a minus, you put the big one. Okay, so this is minus 2, so the big one takes minus, the small one takes plus 2. I think this is a better option to get this. So the answer are plus 2 and so using the zero product property, you can say opposite of plus 2 is minus 2, opposite one, and you're done. Using graphing device, find a solution. Now they gave you this. At the same time, I want to understand what is this ln of x. So there are two. There's an equal sign. What is ln of x, and where did this come from? You see, ln of x is actually logarithm of x to the base 3, and base base e. So that means this is e, which e is 2.7182181, all that irrational number. But the main thing is, remember, if e raised to 2x was this and e raised to 3x was this, then the e raised to, sorry, then e raised to x will be in between this, in between, like this, closer to this one. It will be closer to this one, because this is 2 raised to x, this is 3 raised to x, so this is e raised to 2x, because 2 is less than 3, right? And e is basically 2.7. So basically 2.7 more closer to, that's why the pink color is more closer to the 3 raised. So then when you graph this uh, downward, this 2 raised to x will be something like this, and this e raised to x will be like this, and 3 raised to x will be like this. So the main point is I'm trying to show this is because the graph, you have to graph two things. You're going to graph on the calculator. One is you have x-axis. What does this mean? Okay, that's ln of x. So let's do this is ln of x. Okay, that's ln of x. Let's say this is ln crosses to 1. What is 3 minus x? 3 minus x is like y equals mx plus b, where this is your 3 and this is minus 1. And it has to start with 3. 1, 2, 3. Let's say this is 3. And there's a line where it's something like this. So this is the line, this line y equals 3 minus x. So our question is, where do they meet? So all we can do is just use the calculator and figure it out. Let's go directly to the Inspire and go take a this new no graph. So we have two equations. One is this one. Let's put it like ln. So I have ln of x, and there you go. And I want to also put another equation, another graph, and put the, and then I want to do the second one. Click on the tab, you get the second one, 3 minus x. And you can see clearly they cross each other. So all you do is menu, intersect, and to the left, to the, sorry, I mean, oh God, yeah. And there you go, you got the answer, 2.21. So the point of intersection is what they wanted to know, and you're done. I hope this helps. I'm finishing. So we'll continue with the classroom, and also I want to finish lesson number 4.6 later on. Make sure you finish your homework in Cengage and get as much high grades as possible.